Hello, I'm Brian, WD9QVR for the World Beyond 7.121. Today we're going to start off with a quiz. Which of these items is an antenna tuner? Is it A, B, or C? And there could be more than one right answer. We'll have the correct answer coming up in just a minute on the World Beyond 7.121. I lied. There really is only one correct answer, and that is, of course, A. This is the antenna tuner. And now that we understand what an antenna tuner is, let's see a demo of how it works. And since we've learned all about antenna tuners, let's get rid of it. Because today, we're talking about Transmatches. For probably your entire career as an amateur radio operator, you've heard these devices called antenna tuners. That's really a misleading name. Back in the early days, back even before I became a ham in 1974, they were actually called Transmatches, and that's a much better description of what they do, because a transmatch is an impedance matching device. Nothing more, nothing less. In that sense, it's similar to certain types of balloons or perhaps coils that are used on an antenna. It simply matches the impedance that is expected by your radio, which is typically 50 ohms, to the impedance of the antenna system. So when is using a transmatch appropriate? Well, basically there are three situations. One is if you're using an antenna that's fed with coax that's just a little bit out of resonance. Say, for example, you're using an 80-meter dipole on 75 meters, and you just want to broaden that SWR bandwidth a bit. That's a good use for a tuner, and a situation in which a tuner is not going to add much in the way of loss. Typically, an internal tuner in a rig will allow you to use it as sort of a bandwidth extender, if you will. A second situation in which a tuner is helpful is if you're using a balanced line or parallel line feed antenna, such as a doublet or perhaps a loop or any number of non-resonant but balanced antenna designs. In that situation, a tuner is an excellent tool for matching the impedance of that entire antenna system to your rig and also transferring it to an unbalanced load. A third situation in which the use of a transmatch can be beneficial is if you're using a non-resonant antenna, but you locate the transmatch at the antenna feed point as opposed to in the shack. And then you simply run coax from that transmatch all the way into your rig in the shack. That would be an appropriate use of a tuner as well. So when shouldn't you use a transmatch? Well, that's easy. If you're trying to use a coaxially fed antenna on a band for which it isn't designed, let's say taking that same 80-meter dipole and trying to operate it on 40 meters or 20 meters, and you're using a transmatch in the shack through that coax to try and match the load, that would not be a good idea. The reason being is that coax, regardless of the quality of the coax, becomes extremely lossy as SWR increases. And of course, using a transmatch in the shack does not do anything to correct the performance of the antenna, and it doesn't do anything to eliminate the loss that's in the coax cable. Let's take a look at a chart that shows us just how bad those losses can be. In this example, it assumes that we're taking a 135-foot antenna, typically an 80-meter dipole, and trying to use it on, say, 40 or 20 meters and feeding it with RG8X. As you can see, the loss for the length of this coax cable is enormous. And even if you were to replace the RG58X with, say, LMR 400 or even better coax, the losses are still going to be enormous. This would be an inappropriate use of a transmatch. Again, you don't want to try and force this antenna to operate on bands for which it wasn't designed using coax as a feeder. In that scenario, even if your tuner can find a match, which it probably could, you're still sacrificing an enormous amount of your transmit and receive signal. Not a desirable situation. And while we're talking about feed lines, let's take another quick look at that chart. If you look at the right-hand column, it shows the losses for the same antenna operating on the same bands, but using ballast line. You'll note that the losses are extremely low, in fact, almost zero in effect. This points out a great advantage of using parallel feeders and why using non-resonant antennas with a transmatch and ballast line feed can provide an extremely efficient antenna system. Let's talk just for a minute about power ratings on antenna tuners' transmatches. Over the years, I've known a lot of people that have said, you know, I was only running 100 watts through this tuner and it's rated for 300, but it's still arced inside. Why? Because depending upon the amount of reactance that you have to dial in order to find that match, it can create some extremely high voltages inside the tuner, even if the power you're running is well below the tuner/transmatch's limits. So be aware that depending upon the load you're presenting to the tuner, it can still arc. It's not that the tuner was improperly rated, it's simply that the voltages created inside the tuner are too high for it to withstand. So how do we actually use a manual transmatch? Well, with a manual one, there are a few steps you need to follow. First of all, always tune it for the maximum received noise before you ever transmit. Doing so is going to get you in the ballpark of where that match is. Step number 2 is to apply a low power carrier, meaning AM, RTTY, CW, and then adjust the capacitance, typically these two knobs, for the minimum SWR. If you have a switched inductor tuner, you want to go back to receive before you change from one position to another on the inductor. Then apply a low power carrier again, switching the inductor and the capacitance again through a series of times in order to find the lowest SWR. Now with an automatic transmatch, as the name implies, it does all of that automatically. However, you should be aware that there are basically two types of automatic tuners/transmatches. One would be the standalone, where it's simply inserted in the coax feed between your rig and the antenna load. And then the other would actually have a connection to the radio to either allow the tuner/transmatch to put the rig into a low power transmit mode, or to allow the tune button on your radio to control the tuner. That's a handy feature. So which is better, a manual transmatch or an automatic transmatch? Well, that depends on your situation. A manual transmatch will typically have a little bit more tuning range than an automatic transmatch, but you have to readjust the knobs each time you change from band to band, or sometimes on a frequency within a given band. With an automatic transmatch, it will find a match instantly as you go from band to band. If you're like me, and particularly during contests, you band hop a lot, that I really want it to go to that match right away. I don't want to have to spend time adjusting the knobs. In those situations, I prefer, and in fact I use most of the time, an automatic transmatch. I hope this presentation has been helpful. I hope I've given you a little bit of insight into the world of tuners/transmatches. We really need to get rid of that term antenna tuner because it's all wrong. For the World Beyond 7.121, I'm Brian, WB9QVR, and I'm going to go find my antenna tuner now.